Welcome to Radical Ideas. In today's episode, we have robotics. This is a professional development that we did in January 24th, and we had Mr. Chris Gordon come up from UNCW. He's the Assistant Director for the Center of Education in Science, Technology, Engineering, and Mathematics, or CSTEM for short. Before we get into some of those clips, let me go ahead and introduce, we have with us some other project-based math coaches, Shelley Alford and Mary Weibel. Our PD that we did on the 24th was outstanding. What were some of your thoughts on that, Shelley?
I thought that was just such an amazing day. The teachers got a little verklempt at the beginning when Mr. Gordon was trying to explain to them, they were going to do some coding, and then the computer's coming up, and then the computer's not coming up, and all the technology pieces that went with that. But once we got going and everybody was actually putting in the codes and getting the robots going and doing what they were doing, and then hearing the teachers make the connection with the Common Core, hearing them make those mathematical connections, the connections to the 8 essential standards that they were talking to each other, and all of those little pieces that go along with really effective PD. This was one of those Saturdays where they walked out going, this was a great way to spend a day, you know?
Yeah, it was excellent, and there was a lot of math, a lot more math than some of the participants even imagined could even be. In fact, this was our biggest Saturday ever. We had a lot of folks come out, and it was great. What about some of those mathematical practices, Mary?
Yes, I thought that this was such a cool experience for the teachers dealing with the robotics. Our teachers were immersed in experiencing some of the things and some of the kinds of mathematical thinking that we want our students to engage in every day. Our teachers were working collaboratively to problem solve. They had to attend to precision. They had to reason and explain why they wanted to do something to their colleagues. It was really exciting and really frustrating.
That was the fun part, and not because they were frustrated, but that frustration is what you had said about them and their students connecting.
Absolutely, because a lot of times I think, being math teachers, we forget that math isn't easy and fun to everyone. So for them to experience the type of frustration with the robotics challenge that their students feel sometimes day to day with some of the math difficulties, I think was really beneficial. Because another thing we want to build in our students is the ability to persevere when things get tough. And we do that with collaboration with our colleagues and with problem solving and stepping out of the box. So I think in reflection, the teachers gained a lot from the experience. Just considering what support do I want as a teacher when I'm feeling this frustration, then how can I offer that same kind of support to my students when they're experiencing frustration, and then we can learn and grow from it more.
That to me was part of the really essential conversations that they were having, those critical conversations about how they go back to their classrooms and make this work for their kids, whether they're 3rd graders or 4th graders or 7th graders. They were really talking about, okay, this would be a frustrating thing because, and like there was one time when they put the program in, they put the robot down, and it did not do what they had programmed it to do. So they were like, oh, what is that about? So, and they had to go back and look at the math. And when they said that, that was a conversation that I got to be a part of, was what part of the math are we not getting? And it was that changing a decimal and understanding that when you change that decimal, which way that decimal goes makes that number change so dramatically. And they were like, well, I hadn't even thought about explaining it that way. But they did, and it was fantastic. We had some wonderful teachers that decided, well, I know how I can use this, but when can I use this? And I think that's where we as coaches can help them really get to understand when that can happen in their classrooms.
And I think you'll see that in the clips. We have a few interviews, well, of course, with Mr. Chris Gordon, but also we had Joe Carey from Summersill Elementary, and Kim Carr from Meadowview. Both shared their thoughts on it. But what was really interesting and what's really great about our Saturdays is the teacher plays the students. And you're right. You guys hit it right on the nail on the head. It was so much fun. The 4 hours that we meet flew right by.
At the end, the teachers were like, really? Wait a minute, we're not done yet.
Yes,
you know?
I know.
We had to, okay, we need to wrap it up because the day's over.
This first clip that you're going to see is the square. Remember, they had to have their robot turn in a 90-degree angle and then complete a full square. And so this next clip is you'll see them trying to set that up.
So today, the first thing we're going to do is we are going to get this robot to move in a square. So we're going to get our robot to go in a 30-centimeter square. So there are two different ways we could say this. We could say go forward, turn, forward, turn, forward, turn, or we could say repeat, go forward, and then turn. Now, this computer program that you're going to write is going to be a series of blocks, and it's going to execute the blocks in order. The buttons we're going to be using today to make this go in a 1-foot square, this one here is a medium motor. This one says large motor, so that could be one we're going to use. Move steering, move tank. If you notice on the bottom of your robot, these are the motors, these big, large, square things. And there's 2 of them. So if we move these like a tank, this thing will move together. How are we going to determine 30 centimeters? There are 2 mathematical ways to figure out how far this robot's going to move in one rotation. It's got something to do with their circumference. And pi. And r squared. Can we put all those together? So we can figure out the diameter of the wheel, use the equation to calculate the circumference. Look at the wheel real close. What do you notice? So it's got its diameter right on the wheel. And from what I've been told, that's the most accurate way to do this. Everyone use one of those methods to figure out how far this thing's going to go in one rotation. We have our program to make it go forward and turn. That's what this says. This says go forward with both wheels, 50% power, 30 centimeters, turn. Is it going to be a nice 90-degree angle? It could be, but we have no idea, right? This is where we're going to need to use a little guess and check. It's probably best if we just download it and then try it. So instead of 0.5, what number do you need to make that? Okay, try that and see what happens. From here, you've learned how to turn a nice 90-degree angle, hopefully. If you know a 90-degree angle, can you turn a 45? How do you do that? Half. How about a 30? How about a 25? A little bit of math, you can find them all, right? That first page where we put the table to see how far you go in 1 rotation, 2 rotations, 3 rotations, that's a good place to put a table for turn angles. That way when the students come back together, next time, oh, I need to turn a 30-degree angle. They don't have to sit there for 45 minutes trying to figure out what it is. Will it be exact? No, but they'll have a good place to start. Okay. This is a really super complicated program that we're going to write. I gave each of your groups a number. That's your power level. You're going to switch each of these numbers to that power level. What was your number? 2. So both those are going to be 22s. Everyone see that? So whatever your number was, go ahead and do that. Put that in there. You are going to make a table. It's going to be a rotation and a distance table. So let's go by 5. So we'll go 5 seconds, 10 seconds, 15 seconds, and 20 seconds. Change this to 0, download it, measure how far it goes. Change it to 5, download it, run it, measure how far it goes. You have to download it every time. If you don't, you're going to get the same number. So go ahead and hop on your computer, make a graph in Excel, because you're going to need something fairly accurate to do this activity. The robot is going to start here with its front tires on the front edge. You need to come closest to without hitting and destroying the foam.
I just attended the C-STEM robotics workshop this morning, and it was fabulous. It was interesting at the beginning because we were very frustrated, my group and I were. There was a lot of work with decimals, and we had to get our robot to move a certain distance. At first we were frustrated and lost, but we ended up winning the competition at the end, which was to get as close as you could to the finish line. I can definitely see this being something I use in my science lab, so I'm very happy I attended.
Then the Mars rover, there's 2 ways to drive the Mars rover. One way is you tell it what you want it to do, and it looks at the ground in front of it and says, I can do this is pretty easy, and it does it. The other way to do that is that you send it commands, do this, do this, do this, do this. And the problem is that once you send the commands, it takes like 20 minutes or so to get there, and it runs it. So if it's got a problem and you notice, oh my gosh, it's going to hit that big rock, it's going to keep going. It's going to hit that big rock probably before you can send it the command to stop. So you have to be very precise, and order is important. For this activity, we have a maze back here. So the cartographer is going to go and measure the course and come back with measurements, and then in the classroom you can make a scale drawing, or you can make a full-size replica and tape on the floor. The engineer is going to have to build a device that will allow you to hook this and pull it off. The programmer is going to have to program, but the programmer doesn't know what to program yet until the cartographer comes back with the map. So what you need to do is your robot needs to start here behind the dotted lines. You need to come to here and knock this off. Okay? You guys all have that little hook on the front, so that the engineer doesn't need to build anything this time. If you hit any solid tape, you lose your tires, and you've destroyed the rover. Okay? The thing is that when you stop here, I don't want you to measure this last distance. On your robot, these little eyes right here, this is a motion or a distance sensor. I want you to use your distance sensor to stop when you are 2 centimeters in front of that can. That would put you like right here. Then you can use this to go forward and knock the can off. So today we had teachers engaging in a variety of activities. We started with something very simple, and then after that we expanded and had them make squares with their simple programs. After we did our square, then we did an activity where we learned about different speeds, and we made a graph and a table to determine how far a robot could go in a given amount of time. And we used our cell phones to make sure that they were going to have it stop before it made it too far. And the final activity today was to work on a maze where they had to figure out how to get the robot to go to the end of the maze and then knock something off a container. This is simulating an activity that's more problem-based, where you have a robot that needs to complete a very specific task. And hopefully the teachers will learn that these robots are something that are fairly easy to use, feel comfortable with them, and let their students use them. So hopefully they decided that this is a friendly resource that they can use, and they're not too intimidated with implementing it in their classroom.
I would use this in my classroom to kind of go along with the computer lessons of programming, just doing things in sequence, step by step, to go along with a reading story. Another thing I could use this for is just estimation, how far or how fast things go, forces of motion for science, just using the measurements with math, centimeters and inches and things like that.
And welcome back to Radical Ideas. Those were some interesting clips, were they not?
They absolutely were.
Mary, in that first scene, they were measuring the wheel. Why don't you tell the audience what that was all about?
Yes, well, in the beginning, our first task was to make the robot make a square, and we didn't necessarily have a specific distance, but we had to know when to tell the robot to turn. And in order to do that, we had to know how many revolutions for that wheel it would take to go that distance. So the teachers had to figure out a way to decide how many turns does that wheel have to take to go to this point before it turns and goes on again. So we had to measure the circumference of the wheel and do some calculations to get it to that point, and then adjust and put those decimals into the computer program, and then try it and see what happens.
And with it being that measurement piece, they had to determine what instruments they were going to use to do it, and if they all agreed on, were they going to measure in inches or were they going to measure in centimeters? Were they going to do the distance first or were they going to do the circumference first? And all of those areas that they had to explore within each of those strands of math, they had to go into each of those with some kind of depth in order to get that to work. And so many of them didn't do that at the very beginning, and then they figured out, oh, this is what we need to do, or they watched someone else and went, how'd you do that? And then they talked about that and how they got that distance. That was the other one, was the distance one. Having to get that, and then Mr. Gordon talking about the fact that not only can you do it from here to there, but what if you wanted it to turn and return? What math comes into that? And that's when they talked about that elapsed time that could be brought into there. And that elapsed time can be not only those younger kids, but it can really get in deep in those older kids. And then the distance, the measurement, all of those areas that we explored in major depth. That was interesting. And again, back to the decimals, that was a very good use of mathematical language within this whole workshop. That worked out good.
The decimals was definitely a huge part of it. You saw the teachers really getting into it, even videotaping it with their cell phones.
Oh, the competition was fun because they weren't sure what they were competing for, but they decided they were going to be the ones that had to program their robot to get it as close to the line without going over. And in the square where they had to make a turn and then knock over the cup, the number of times they had to go in and readjust their measurements and the conversation of hearing them say, I'm not sure I allow my students this much time to readjust in the classroom. And that goes back to either the 8 mathematical practices or delving deeper into each of those standards that you're exploring and allowing the kids that time that it takes in order to get them to the depth of understanding for that. And then trial and error. The trial and error.
Yeah, this was the perfect project-based math experience because, like you were talking about, we didn't say, okay, you're going to have to measure in centimeters or you're going to have to do this. It was wide open. So just by the nature of the task, the teachers wanted to know what to do. And that's what project-based learning does, is it gives you that driving question and it makes the kids want to learn what they need to do in order to accomplish the task or the project. So it builds the desire for learning, and it's that avenue then to get to the math that you're looking for them to learn how to do.
Within each of the strands that were brought forward to them. The data collection alone, the different types of data that we had to collect, the different types of displaying the data that they made that choice in doing, that was amazing because of all of the different choices, and then them looking at each other saying, oh, I like that, I'm going to borrow that idea. Oh, I like that, I'm going to borrow that idea.
And that was really great to see. And the teachers, the little showboating at the end, just using those EV3s, our Lego Mindstorm EV3s, which we have several of them.
In the cage.
In the cage, our equipment loan program. Oh, and in fact, we even have a clip of that where we view the cage. The teachers really need to see this. Let's run that clip of the cage. So here we are at the county office, and and I'm going to go ahead and take you on a tour of our cage. And here we are at cage number 12, and you can see every day I get more and more equipment in. Here's some robots that I just got from UNCW. As you know, C-STEM is a partner with our grant, and I'm constantly trying to find room in this cage to go ahead and put new equipment. So check our Weebly, because we're always updating our Google Doc with our equipment loan program. First thing we have is all the stuff from the Buck Institute for the PBL 101. When they come in, here are cups and pens and the different books and stuff that we have that we hand out to the teachers who attend that PD. Here are some of the bag of books. We have 4 different sets of those. This section right here is all our Singapore math. This right here, we started off with just one of these. For 3rd grade, the Mathological Liar. Teachers liked so much, so we went ahead and branched on and got 4th grade, 5th grade, and 6th grade. All this, by the way, on the Google Doc. Check it out. I bring it right to your room. Singapore Math. These are fairly new. This is our flight simulator, smaller package than our older ones. Back over here, we have all of our math kits. As you can see, most of them are out. Teachers are really using this. This whole shelf would be filled with these math kits that we have. This is all equipment that you can check out. Visit our Weebly, look at our equipment loan program, go to that Google Doc. This is all for you. And that was a little clip of our cage, which is our equipment loan program. If you visit our Weebly, project-based math, Weebly.com, you'll see a plethora of different equipment and resources to go ahead and check out. Project-based math is there for you. Tap into it. The resources are there. We have a lot of exciting things coming up. Mary, you wanted to share something that you're pretty interested about.
I am so excited about the upcoming PD we have at Sturgeon City. This one is called Living Math. I made that one up. I thought it was pretty good. Because what we're doing is looking at the math that lives in the world around us. The teachers are going to be working with some water quality experiences, some soil filtration, and biosampling, and using their hands-on experiences to connect to the math that their students are going to be using and learning in their classrooms. I'm really excited about this one.
Well, that sounds exciting, Mary. And the next time we do Radical Ideas, we'll be sure to showcase Living Math. On behalf of Radical Ideas and Project-Based Math, Mary Weibel, Shelley Alford, and myself will bid you farewell until next time.